Hi everyone. In this lesson we're going to be talking about some very important mathematics, especially in regards to calculus. The first thing we're going to talk about is a number that you've probably heard of in high school and have been wondering about ever since, and it's this little number called e. Where does it come from and what does it mean? Well, let's say that we have a function, f of x, and this function is equal to a to the x. Okay? Now, you might wonder, how would you go about taking the derivative of this function? Now, in order to find the derivative of this function, we're going to use the limit definition of the derivative, and we're going to say that d dx of f of x is equal to the limit as h goes to 0 of our function a to the x plus h minus a to the x all over h. Now, when you learned about exponents, you know that when two exponents are being added, you can just simply multiply them since they have a like base. So this becomes the limit as h goes to 0 of a to the x times a to the h minus a to the x over h. Now, since we have an a to the x, both terms in the top, we can pull that out. So we get the limit as h goes to 0 of a to the x times a to the h minus 1 over h. So I'm going to pull that a to the x out because it's simply a constant and it's not dependent on h. So we get that a to the x times the limit as h goes to 0 of a to the h minus 1 over h. Now let's look at this term right here. So if we look at this part of the equation, we know that this is simply a constant. The derivative of 0, actually. And this is some constant c. So what we know is that the derivative of a to the x is simply this constant times a to the x. So this a can change, and for some number we can find that c is equal to 1 for a certain a. And what we find is that this a is actually the number we call e. This e is approximately 2.718, and then it goes on for some time. You've learned that in high school. So now that we have that e to the x, the derivative of e to the x is e to the x. And this is going to be extremely important when we go to find the derivatives of logs. So what we're going to do here is we're going to see that if we have some function, maybe y equals log base e of x, we're going to see what the derivative of that is. And so what we do is we take the derivative of both sides. We find that this equation can also be written as e to the y equals x. So we take the derivative of both sides. Derivative of e to the y is going to be e to the y dy dx. And the derivative of x is equal to 1. So then we divide by e to the y, so we get dy dx is equal to 1 over e to the y. Now we know that e to the y is equal to x, so we get that the derivative is simply equal to e 1 over x. So the derivative of the log base e of x is equal to 1 over x. Now, e comes up so often in mathematics that this log base e has a special name. In fact, we call it the natural log, written as ln of x. So the derivative of the natural log is equal to 1 over x. So now from here, what we can do is finally solve what the derivative of a to the x is. So if we have a function, y equals a to the x, so to find the derivative of this, we take the log of both sides, so we get natural log of y is equal to the natural log of a to the x. Now, those who have studied about logs know that when you have an exponent within the log, you can simply bring that out. So this is equal to x times the natural log of, is simply x times the natural log of a. So now what we're going to do is take the derivative of both sides. So the derivative of natural log of y is 1 over y dy dx. And then the derivative of x natural log of a is simply natural log of a, because the x goes away. So then we can multiply both sides by y, and we get the derivative is equal to y natural log of a. Now y is equal to a to the x, so what we finally get is that the derivative of a to the x is a to the x natural log of a. So that's what the derivative of a to the x is. So now that we know all these facts, we can go on and solve more difficult ones. Okay, so if we have the function y equals log base b, so any number of x, let's find the derivative of this. So we can rewrite this again as b to the y equals x. And we'll take the derivative of both sides just like we did before. So the derivative of b to the y is b to the y log, natural log of b times dy dx. And then this is equal to the derivative of x, which is just 1. Now, b to the y is equal to x, so we can substitute x in there, and we get that x natural log of b dy dx is equal to 1. Dividing x natural log of b to the other side, we get the derivative is equal to 1 over x natural log of b. So therefore, the derivative of a log with any base is simply written as 1 over x natural log of that base. So now that we know all these rules about logs and their derivatives, we can use them to find the derivatives of any functions pretty much. So let's say we have the log base 3 of x. The derivative of this would simply be 1 over x natural log of 3. Just that simple. So now let's say we have the function maybe sine of e to the 2x. To find the derivative of this, we have to remember chain rule when we do this. This becomes derivative of sine is cosine. We'll keep the inside. Then we multiply by the derivative of the inside. Now the derivative of e to the 2x is e to the 2x times derivative of the top, which is derivative of 2x is 2. We multiply by 2. So that's the derivative of this function. Say we wanted to do the derivative of more complex functions, such as the natural log of sine of x squared. So again, don't get overexcited, but we just use chain rule again. So when we have a log, we do 1 over the inside times the derivative of the inside. Now, derivative of the inside, sine of x squared, is cosine x squared times the derivative of the inside of this function, which is 2x. Let's do one more example, and let's just do, let's say y equals e to the kx. Now this function is extremely important in the rest of your mathematics. It comes up in the later calculus courses along with your other science courses and pretty much anytime you're doing exponential growth, which you'll also do later this calculus. So what we do here is we take the derivative of both sides and we find that dy dx is equal to k times e to the kx. Now, e to the kx is simply y. What we find is that the derivative of y is equal to k times y. And this is extremely important in any time you're doing exponential growth and other things like that, population models, all kinds of things. So, thank you very much.